Hello everyone, I'm Ashok. Welcome to another video on machine learning and data science terminology series. In this video, we look into a term called autocorrelation. I assume you understand what is correlation. Correlation is a coefficient. It's a ratio which which gives relationship between two random variables. For example, if you're trying to find a correlation between x variable x and variable y, uh, correlation coefficient is equal to covariance of x comma y divided by standard deviation of x variable and standard deviation of y variable. This is called as correlation coefficient, and the value of correlation coefficient varies between -1 to +1. The positive side is called as positive correlation, which means when one variable increases, other variable also increases in value, and vice versa. A negative correlation means one variable increases the value, another variable actually goes down in the value. Okay, and I have a video explaining correlation in detail. You can check that out. What is autocorrelation, right? So whatever you say auto, for example, autobiography, you talk about like it's your own story. So auto means to yourself. Okay, when you correlate variable to its own, to itself, and with the time lags, we call it as autocorrelation. So what do you mean by that? um, let's say I have car sales of various months. So I'm gonna say January, February, March, April, May, June, etc. Okay, and let's say I have sold 200 cars in January, 250 cars in February, 220 cars in March, 280 cars in April, 250 cars, 260 cars, for example. Okay. Great. So if I plot, let me call this car sales as simply Y. It's easy to represent. Okay. If I take a Y correlation with Y itself, what do you get? You get one, isn't it? So the correlation, if you correlate Y with the Y itself, is one. So that forms your first. Then what we do, we actually lag. We say one time unit lag. Okay, and what do you mean by lag? So we'll say t yt minus 1. So it means that you're going to push these numbers a bit. So the January sales actually becomes February sales, February sales become March sales. So you're just like kind of like pushing it a bit. So this and this values become absolute. So this series is actually one lag series, and this is actually original series. This original sale is a one lag sales. Okay, and then you plot a correlation between uh, y with y one lag. Okay, so if you do one lag, then you definitely don't get one because they are two different series, and probably let's say you get about zero point 0.9 or 0.7 for example. Okay, zero point 0.7, and you lag one more time, it's a 2 lag, so you might get something like this, and then zero point 0.3 lag, and then at some point of time it actually turns negative and again goes positive, and it actually goes, if you try to see that, it looks more like this and it dampens out. Okay, and this is autocorrelation, and this plot is called as autocorrelation plot, or simply ACF, AC autocorrelation function plot, so ACF plot. Okay, and what's the importance of autocorrelation? Well, this is used in time series analysis, so time series forecasting. So for any time series forecasting, when you use a time series forecasting, we're going to forecast the car sales, let's say for the months. Okay, and if you if you want to do any time series forecasting, the data needs to be stationary. I understand this another complete term. Stationary. Stationary means, okay, the data is not having a trend and it is not in a very different intervals. It's more like a stable around a certain mean. Given a okay, so if the data is stationary or not stationary, is it can be visually found by looking into autocorrelation plot. If the autocorrelation plot is decaying like this, like slowly, it's like a gradual decay, then we call this as non-stationary data or not stationary. If your autocorrelation function plot decays like instantly, like this. So one you have, and second one is actually instantly decayed, and then like this, and then like this. Okay, this is stationary. Okay, that's one of the primary application of autocorrelation function plot. By looking at autocorrelation function plot, we can determine whether a given data is stationary or not stationary. And why are you worried about stationary, not stationary? Because your time series forecasting requires data to be stationary. Okay, and if it is not stationary, we need to convert that into stationary. And there are multiple techniques of converting, and differencing is one of the primary techniques for converting a non-stationary into a stationary data. But that is autocorrelation. I have a quick graph. Okay, so this is a simple autocorrelation graph. I'm importing pandas, and I'm importing a car sales, which is just exactly what I've shown here. So it shows different months and the sales figures next to it. And when you look at the plot of it, you can see that the sales is going up over a period of time from 2016 to 2018. It's gradually increasing. Okay, and this is not stationary. I can already say, because it has a upward trend going on. If you plot an autocorrelation plot, you can find this autocorrelation function from a stat models graphics.tsa plots. Import plot underscore ACF, stands for autocorrelation function. I'm plotting this, and you see that you have an autocorrelation plot which is very similar to what I have drawn, though mine is not symmetrical. Okay, so it's also same. So this is autocorrelation plant, and by just looking at this, I can already say that this data is not stationary because it's gradually decaying. Okay, and one of the techniques to make it stationary is by differencing. When you say differencing, we we take this data. For example, let's say 200, 220, whatever data I have over here, 250 and 260 and 280. We difference it, means that this original data, when you difference it by one time, one order, we will take a distribution by differencing from the next value. So for example, this is like no value. 250 minus 200 is 50, 60 minus 50 is actually 10, 80 minus 60 is 20. So this is called as differenced by one order. Differencing is one of the techniques which will make data more stationary. So I'm doing one differencing over here by using a diff function, and then when I plot it, you see that autocorrelation plot decays instantly. All right, thereby saying that the data is now stationary. You can use one order difference data for your time series forecasting. Okay, I understand there are many terminologies apart from autocorrelation. They are very related. So I suggest you look at them individually, and that gives a context for your autocorrelation. All right, that's autocorrelation. And to summarize it very quickly, autocorrelation is related to time series forecasting, and autocorrelation is used to understand or plot autocorrelation function plot, which tells you whether a data is stationary or not stationary. If the graph decays gradually, then it is not stationary. If it decays like instantly, quickly, then it is stationary. And we are worried about stationary or not stationary because for time series forecasting, we need the data to be stationary. And to make a non-stationary data a stationary, we can use differencing technique. Okay, that's a quick summary. Thank you very much for watching this video. If you like the channel, please click subscribe and click notification button. I'll see you in the next video.